Hello, today I'll be reviewing my latest retro computer, a Heathkit H8 inspired design. The H8 is the last system I needed to complete my Heathkit collection. If you try to buy one on eBay, good luck. A basic unit generally in mediocre shape or not running sells north of $2,000. Members of the Society of 8-Bit Heathkit Computerists designed many upgrades to this venerable computer from the 1980s, vastly improving capability while maintaining compatibility with the original design. Many CBIC members contributed to this effort via Discord. The cost for this implementation was $700 for the printed circuit cards. The case took around a month to design and $60 to 3D print. This video has 3 sections: introduction, 3D case design notes, and gameplay. The design starts at 4 minutes 30 seconds and gameplay is at 10 minutes 20 seconds. The CPU and video card were designed by Les Bird. The Z80 CPU card runs up to 16 MHz instead of the original 2 MHz. It also uses the ROM WBW boot ROM that provides a commercial-grade implementation of CP/M and similar operating systems and applications for retro computing hardware systems. The CPU features 512K of banked RAM set up as RAM drives and a compact flash drive providing 8 8-megabyte drives. The newly designed video card uses a Tang Nano 9K FPGA to provide HDMI output, emulating a TMS 9918 video chip. Audio is provided by an AY38910 audio chip. An ESP32 provides Bluetooth connectivity for modern game controllers. Les designed the system to support MSX games. MSX is the standardized home computer architecture announced by ASCII Corporation on June 16, 1983. It was initially conceived by Microsoft as a product for the Eastern sector and jointly marketed by Kazuki Nishi, the director at ASCII Corporation, per Wikipedia. Now a little bit about my contribution: designing the 3D H8 case. It is based on the original Heathkit design, documented by Norberto's son using SolidWorks. His work was converted to STLs for measurement using Onshape. Several CBIC members provided measurements of real H8 cases to help the project. I used the hobbyist version of Autodesk 360 to design the components for 3D printing. My Bamboo Labs X1 Carbon has a max print size of 256 by 256 by 256 millimeters, requiring the case to be printed in several sections. The sides, front, and back needed to be printed in 2 sections. The top and bottom were divided into 4 sections. The bottom of the case was reinforced with 2 aluminum bars to ensure structural integrity. 4 methods of connecting the sections were used. The sides used a tongue and groove. The bottom and front panel were secured using brass inserts and machine screws. The front panel also uses interlaced fingers to align the 2 sections. The top and bottom use a combination of slots and tabs similar to tongue and groove for the sides and interlaced tabs. The tabs are attached using Loctite superglue, not Gorilla. Several parts are redesigned for 3D printability. Originally, several sections were printed vertically. After a failed vertical side print, several sections were updated to allow for printing on a larger flat surface. I learned a lot completing this project. You can use the slicer to only print a section of the print for test fitting parts. This saves a lot of time and material. Getting a good design for the red lens took a lot of effort and 5 designs before I made one that looked good and was actually printable. I bought Bamboo Labs Effects build sheet with my last filament purchase. You can see the embedded stars on the lens faceplate. It's a pretty cool effect. The project was printed using PETG high-flow filament instead of PLA for greater strength and temperature resistance. Infill was set at 20% using a gyroid pattern. Top and bottom layers were set to 13 and walls were at 6. This was particularly important for prints that use brass inserts to provide enough solid material when melting the inserts into the print. Ironing was used for the Heathkit badge on the front. There are pictures to show the benefits of ironing. The component animation in the next section shows a simple version of the top. The 3D printed top was done in a separate file due to the excessive resources it required to render the mini louvers. I hope you enjoy reviewing the rest of this video. Have a great day. I'm nearing the end of my H8 3D printed case project, and I need to go ahead and label the keypad with the numbers for the ROM WBW based system that I'm building. So I've printed out rows of labels, 4 buttons to a row, with the P-Touch printer, and in order to cut that, I went ahead and 3D printed a template that allows me to load the label into the template like this. And then assemble the holder on the other side so the label is securely included in the cutting template. I put the template down, hold it securely, take an X-Acto knife, and simply slice across the lines. Dang it. Oopsies. Oh well, let's move on to the next game.